Welcome back to the channel. We can now upskill your test knowledge by learning the basics of mutation testing. This is not a common skill, and the tests are designed to prove the effectiveness of your test cases. It could be a valuable few minutes of your time, especially if you are asked about this in an interview, so stay with me. Mutation testing is a method to measure the effectiveness of your test suite by introducing small changes, or mutants, to the code and checking if the test can detect these changes. It helps create robust and reliable tests by introducing changes to your code and checking if your test can detect them. This will measure how effectively the test suite identifies bugs. Let's look at a forced mutation with a simple Java method. This is how a code fragment should look. Then we mutate it by replacing an operator. The plus operator is replaced by a minus operator. On the first example, which is now highlighted, we would input A as 5, then add B as 3. The result is a total of 8. However, when using the same numbers in the second example, the result would be 5 minus 3 equals 2. Your test case would be expected to pick this up as an error because it contradicts the expected result, meaning the mutant has been captured in your test case. Best practices include starting with small components and carefully adding mutation tests into your integration and development pipelines. Doing too much initially is likely to introduce errors. Mutation testing also comes with challenges like performance overhead and how you handle equivalent mutants. I just mentioned equivalent mutants, so let's look at an example. The first and correct code extract is looking for a value of greater than 10. The second extract of code contains a mutant. It is looking for a value of greater than or equal to 11. Both formulas will return exactly the same result when you are using whole numbers or integers, meaning that your mutation test will not identify this error. In this case, a code inspection would be a more efficient way of finding these. Let's have a look at another type of mutation. This time it's an error on a constant value. This is an extract of code that calculates the total cost of an item, including tax, at the rate of 10%. Here is the same code, but this time with a mutation on a constant value. The tax rate has been incorrectly set as 0.2 or 20%, so it should be picked up as an error by your test. In case you're wondering, this is how your test case may look. It's designed to verify the correct calculation of total cost using the original tax rate of 10%. Take a few moments to look at how it is constructed. If you are not familiar with Java, then you will need to learn the basics if that's what you are testing. To measure the effectiveness of your test cases, we would use a mutation score. First, we generate mutants using tools like Pit, MutPy, or Striker. Then, we execute a set of tests to kill these mutants and evaluate results using the mutation score. In this example, there are 50 tests. A mutation score is simply a count of how many mutations were identified and therefore killed, compared to the number of mutations that were missed by your test cases. Regarding test tools, Pit is used for Java, MutPy would be used for Python, and Striker for JavaScript. Choose a tool that fits your technical stack and try a quick demo to see results. To wrap up, today you've taken the first steps in learning about mutation testing, its workings, and its importance in ensuring your test cases are robust. I encourage you to try mutation testing with your own code base for better results. For more testing insights, use the link below this video. There's lots of useful lessons there, and please subscribe to the channel. It helps us to create more free content. If you found this video useful, please hit the like button for me before you go. Keep testing and improving.